Hello everyone and welcome to the lecture on AWS Lambda. So this lecture will contain all these topics. What is AWS Lambda? When to use Lambda? Use cases, file processing example, streaming example, web applications example, IoT backends example, mobile backends example, key features, sample Lambda function 1, sample Lambda function 2, advanced features in AWS Lambda, asynchronous invocation, event source mappings, destinations, and Lambda integrations. So what is AWS Lambda? You can use AWS Lambda to run your code without needing to set up or manage any servers yourself. It is 100% serverless. Lambda takes care of all the background work. It runs your code on reliable systems and handles server maintenance, operating system updates, providing the right amount of capacity, automatically adjusting resources, and keeping track of logs. Your main job is just to provide the code you want to run. You need to write it in one of the programming languages that Lambda supports. You group your code into units called Lambda functions. This helps keep things organized. The Lambda service is smart. It only runs your function when it is actually needed and automatically adjusts the resources to handle the load, whether it is small or large. You only get charged for the time your code is actually running, the compute time. If your code is not running, you don't pay anything. So when to use Lambda? Lambda is an ideal compute service for application scenarios that need to scale up rapidly and scale down to zero when not in demand. For example, you can use Lambda for file processing. So use Amazon Simple Storage Service S3 to trigger Lambda data processing in real time after an upload. Stream processing, use Lambda and Amazon Kinesis to process real-time streaming data for application activity tracking. Transaction order processing, clickstream analysis, data cleansing, log filtering, indexing, social media analysis, Internet of Things, IoT device data telemetry, and metering. Web applications. So you can combine Lambda with other AWS services to build powerful web applications that automatically scale up and down and run in highly available configuration across multiple data centers. IoT backends. So you can build serverless backends using Lambda to handle web, mobile, IoT, and third-party API requests. Mobile backends. You can build backends using Lambda and Amazon API Gateway to authenticate and process API requests. Use AWS Amplify to easily integrate with your iOS, Android, web, and React Native frontends. So this is the file processing example. So first, photograph is taken and this is the initial action where a user or an automated system captures a photo. Second, Amazon S3, once the photograph is taken, it is uploaded to S3. Then Lambda is triggered. After the photo is uploaded to S3, it automatically triggers a Lambda function. The triggered Lambda function contains the code that performs image resizing. This means that Lambda will take the uploaded image and resize into different versions suitable for various devices such as browsers, mobile phones, and tablets. Then lastly, the result of this Lambda function is a set of resized images that are optimized for different screen sizes. And this is particularly useful for websites and applications that need to display images correctly across a range of devices. And this is a streaming example. So first we have Amazon Kinesis. This captures real-time social media data streams. Second, Lambda gets triggered. The data stream triggers an AWS Lambda function. And the Lambda function processes the data to extract hashtag trends, for example. Then DynamoDB, which stores the trending data. And data querying. So the processed data is immediately available for querying by business users, likely for analytics or reporting purposes. And this is a web applications example. So first we have S3. This hosts the front-end code for weather application. Then we have user interaction. A user requests local weather data by clicking a link in the application. Then comes Amazon API Gateway. The app calls an API endpoint through API gateway to fetch weather data, and that invokes AWS Lambda. The API gateway triggers a Lambda function, and the Lambda function, this function retrieves weather data from DynamoDB, and DynamoDB stores the weather data, which Lambda retrieves and sends back to the user. Next example is IoT backends. So we have tractor sensors. They send data to Amazon Kinesis. Amazon Kinesis captures and streams sensor data. Then AWS Lambda, triggered by Kinesis, runs code to analyze the sensor data. Then Lambda, it detects data trends, identifies anomalies, and arranges orders for replacement parts if needed. And finally, an order for parts is automatically generated. This is a mobile backends example. User posts a status update. The post triggers an API gateway. The API gateway invokes an AWS Lambda function. Lambda checks the user's friend list and sends out notifications. Amazon SNS delivers the status update notifications to the user's friend. So next, I will talk about the key features. So first, environment variables. You can use environment variables to adjust your function's behavior without updating code. Next, we have versions. You can manage the deployment of your functions with versions, so that, for example, a new function can be used for beta testing without affecting users of the stable production version. Container images. You can create a container image for a Lambda function by using AWS provided base image or an alternative base image, so that you can reuse your existing container tooling or deploy larger workloads that rely on sizable dependencies such as machine learning. Then Lambda layers. You can package libraries and other dependencies to reduce the size of deployment archives and make it faster to deploy your code. Next feature is Lambda extensions. You can augment your Lambda functions with tools for monitoring, observability, security, and governance. Next feature is function URLs. You can add a dedicated HTTP or HTTPS endpoint to your Lambda function. Seventh feature is response streaming. You can configure your Lambda function URLs to stream response payloads back to clients from Node.js functions to improve time to first byte, also known as shortened as TTFB, performance, or to return larger payloads. Concurrency and scaling controls. So you can apply fine-grained control over the scaling and responsiveness of your production applications. Next available feature is code signing. So you can verify that only approved developers publish unaltered, trusted code in your Lambda functions. Private networking. So you can create a private network for resources such as databases, cache instances, or internal services. Next feature is file system. So you can configure a function to mount an Amazon Elastic file system to a local directory so that your function code can access and modify shared resources safely and at high concurrency. 12th feature is Lambda Snap Start. So Lambda Snap Start can provide as low as sub-second startup performance, typically with the Lambda function. So this is a sample Lambda function. So we start, this is a Python example. So we start with import JSON and logging, and then you configure the logging. This will set the logging information to CloudWatch. Then we define, so this is the entry point. So the name or stays the exactly same Lambda handler, and you have to provide this too. So similar to Java, I have public static void main. So this will have a exact this signature and event and context object. And then we have a just these are the comments. This is basic AWS Lambda function. There are two parameters that it will expect or it will get inputted: event, which is a dictionary, input data passed to the function, and the context, which is the Lambda context, runtime information provided by AWS Lambda. Then it will return a dictionary, which is a response containing greeting and execution details. So this event input and dictionary output is basically a kind of a JSON object. Then we are just doing some logging like f string. So we are receive event and it will just dump the whole event. So this is the input, right? And we are just dumping it onto the console for logging. Next, we extract name from event if provided, otherwise use default. So this is a hello world kind of a Lambda function. So in the JSON event, this is an input, right? So we are extracting from dictionary the name of the student. So default is this, otherwise whatever we have provided in the input, that will override this value, and finally it will return a simple response, and this is the dictionary here, and its status code is 200, and this is a string hello, whatever name of the student you have provided, welcome to AWS Lambda. And the function name it gets from this context object, whatever function, whenever you save it, whatever name, that will be printed out, and how much time is remaining out of, like total 15 minutes is the duration, and how much time is still left. So this is how you will configure the test event. So this is what we are passing, and when you run the Lambda function, this is how the output will look like. It will return 200 status code, hello John Doe, welcome to AWS Lambda, whatever function you have provided, and this is just illustration, the remaining seconds in milliseconds. This is second Lambda function example, and again we start with importing two libraries. Then we are just doing logging.info and getting the logger and the entry point. So here we are calculating, getting the length and width parameters from this input event object. The runtime converts the event object to a Python dictionary. Then we are extracting the length and width from this JSON object event, and we are calculating the area. So we are passing length and width, and then we are printing it out using a string. We are saving the area to this variable, and then we define the function for calculate area. We return the value, it gets stored here, and finally we are doing CloudWatch logs group name. We are just printing it out from the context, right, and return the calculated area as a JSON string. So we are creating a data variable and area. We are constructing a JSON object, area and the actual value, and return the JSON dump of the data variable. So this is the whole function, and to test it, we'll have event object like length and width, and this is how test result will look like. So status succeeded, and the test event name and the response and the logs will be printed out. So next, advanced features in AWS Lambda. So first we have scaling. So AWS Lambda automatically scales your application by running code in response to each trigger. The function's execution increases or decreases automatically, ensuring high availability and performance. Concurrency controls. So you can manage the number of simultaneous executions of your Lambda function to optimize performance and prevent overconsumption of your resources. Function URLs. So you can directly invoke your Lambda functions via dedicated HTTP URLs, simplifying the integration with web-based applications. Asynchronous invocation. So you can execute functions asynchronously to improve throughput and reduce latency. This method queues messages before processing, enhancing reliability. Event source mappings. So you can connect your Lambda function to external sources like DynamoDB, Kinesis, or SQS, and that allows for real-time data processing and interactions. Destinations. So you can define where to send data after your Lambda function executes, enabling seamless data flow to services like SNS or another Lambda function. So in next few slides, I will detail more information about event source mapping, destinations, and function URLs. Function blueprints. So these are predefined templates for Lambda functions that help you get started quickly with common use cases, reducing development time. Testing and deployment tools. So you can utilize integrated tools within AWS for testing your Lambda functions and deploying them efficiently, ensuring reliability and scalability. And lastly, application templates. So you can start your project with application templates that provide a pre-configured set of resources and Lambda functions, accelerating development and deployment. So this is the one. 3 features I will talk a bit in detail. These are asynchronous invocation, not the function URL, asynchronous invocation, and event source mappings and destinations. So first, asynchronous invocation. So this in AWS Lambda queues events for processing without waiting for the function to complete, unlike synchronous invocation, which waits for a response. When an event is invoked asynchronously, Lambda queues it and immediately returns the success status to the caller. Lambda automatically attempts to retry the function invocation if it fails due to errors or throttling. Users can customize error handling behavior, including retry attempts for asynchronous invocations. Failed asynchronous invocation events can be automatically sent to a configured dead letter queue (DLQ) or another specified destination for later analysis or reprocessing. Next important feature is event source mappings. So event source mappings link AWS Lambda functions to process items from Amazon SQS queues, simple queue service, Kinesis streams, or DynamoDB streams. Lambda uses these mappings to read items from the source service. Items are read and sent to the Lambda function in batches, potentially containing hundreds or thousands of items per batch. Event source mappings maintain a local queue for items and automatically handle retries if the function encounters errors or throttling. You can customize the batching behavior by setting the batch size, that is number of items, and batching window, time duration. Failed items or batches can be automatically sent to a designated destination like SQS queue or SNS topic for error handling or analysis. For SQS, Kinesis, and DynamoDB streams, Lambda actively posts the source for the new items. The Lambda function is invoked synchronously with each batch of records received from the event source mapping. Okay, next feature is destinations. So AWS Lambda allows directing results of asynchronous invocations to destinations like queues, topics, functions, or even buses. You can configure separate destinations for successful and failed asynchronous invocation records. Invocation records sent to destinations include details about the event, the function's response, and the reason for sending. For stream-based event sources like Kinesis or DynamoDB streams, Lambda can send records of failed batches to a specific queue or topic. These stream failure records contain metadata about the batch and information pointing to the specific items within the stream that caused the processing failure. So these are all the Lambda integrations, and this list is growing. And as of this recording, these are Amazon Alexa, managed streaming for Apache Kafka, self-managed Apache Kafka, API Gateway, AWS CloudFormation, CloudFront, which are Amazon CloudFront, Lambda at Edge, Amazon EventBridge, CloudWatch Events, Amazon CloudWatch Logs, Code Commit, Code Pipeline, Cognito, AWS Config, Amazon Connect, Amazon DynamoDB, Amazon Elastic File System, Elastic Load Balancing, and inside that, Application Load Balancer, AWS IoT, Internet of Things, IoT Events, Amazon Kinesis, Amazon Data Firehose, Amazon Lex, Amazon MQ, Amazon Simple Email Service, Amazon Simple Notification Service, Simple Queue Service, Simple Storage Service S3, Amazon S3 Batch, Secrets Manager, Amazon VPC Lattice, and AWS X-Ray. And that's all. Thanks for watching.